Today, we're going to talk about using dbt Cloud to generate analytics and ML-ready pipelines using both SQL and Python. We're going to get going fast using Formula One data and Snowpark. I've got my McLaren Formula One cap on, so let me introduce myself, and then let's get started. So I'm Hope Watson. I work at dbt Labs as a partner engineer. And prior to that, I spent 5 years as a data scientist and also studied biostatistics. The mantra for today's talk is going to be that clean data pipelines are 99% of the battle. It doesn't matter whether you need to do descriptive analytics and create your company's KPIs, or you need to deploy a machine learning model. At the end of the day, you need clean data. I'm going to show you how dbt enables that. Feel free to reach out to me on both my email and LinkedIn. I'm more than happy to always talk data. So if there's one slide to pay attention to, it's here today. It's in my TLDRs here. And the first thing is that we're going to be working all in dbt. So we're deploying SQL and Python code from a single interface, and this is dbt. We don't need separate orchestration tools just because we're using two different languages. Second thing is that we're out of notebooks and into scripts. This is paramount for scalability. So we're going to get out of using Jupyter notebooks. We're going to make our work visible to other members of our team, and it's going to be in .py files. And we can run this on an automated schedule now too. The third thing that we'll be doing is showing how easy it is to deploy dbt Python. It takes about 2 minutes, even less than that. So we just need to make sure that we're on dbt version 1.3. And to get all the amazing packages, we're going to make sure that we've got Anaconda set up on Snowflake. So the way that this is going to be broken down today, we're going to do a quick dbt overview. We're then going to look at our new features. So both Python for dbt and Snowpark for Python went GA about 2 months ago. So we're going to see how we can put these features together and get more out of them than if we just did separately. We're then going to go into our use case, our Formula One use case and demo. So we're the company, dbt Labs, that's venture-backed, that makes dbt the product. So why did dbt even come to exist? Like, how did we get here? And there's a couple things that happen. The first is that cloud warehousing has changed and made it a lot cheaper to transform your data in place. So it used to be really expensive, and you would try to push that transformation upstream outside of your data warehouse. Now with cloud computing, and you have elastic storage and compute, in addition to paying for only what you need, you're able to transform and clean your data within the warehouse and use Snowflake to do that. So cloud warehousing changed, but transformation hadn't changed. It still looked the same as it did 20 years ago. So you had traditional ETL providers, and these are kind of these all-in-one tools, these really big tools that people would specialize in and get trained up on. And then you also had very specialized technical people creating custom code and schedulers. But it leads to the same problem, which is that few people become specialized on one thing. It becomes error prone. And then when that person leaves, you may not be able to reinvent or figure out their work. And you lose track of those KPIs and those dashboards that they had created through these mechanisms of transformation. So the viewpoint here is we're going to build data like we build applications. So we're going to unite on SQL. dbt is now SQL first instead of just SQL only. So we're about to talk about Python in a minute. But SQL is used really by everyone who knows data, and it's provided and supported on every cloud warehouse. We're going to work like engineers. We're going to think about modularity and testing, continuous integration development. And this is going to help both the quality of our data, so people actually believe us when we give them numbers and we give them things like revenue. But we're also going to be able to do it in an automated way. So we've added Python. Why are we enabling Python at this time? There's a lot of SQL users, there's a lot of Python users, and we have that overlap there in the middle as well. And I've definitely fallen into that category. Lots of people in data science and analytics engineering have this overlap. And generally what we believe is that SQL users have benefited so much from using the dbt framework to both modularize their work, all that stuff that we talked about. And we think that it makes sense as a natural extension to allow those capabilities for Python. Python is also very frequently used to manipulate and transform data. So it really just blends it together very nicely. So why does Python matter? We just talked about this. We're increasing those number of data practitioners we can enable. We have Snowpark for Python, and we want to get the most out of Snowflake's capabilities with using Snowpark for Python now. We're going to deploy Python and SQL code from a single place. We already talked about that, no separate orchestration. Certain transformations are just more elegant and low code in Python. So we have our 14-day moving average in Python, and we have it in SQL. And we're using that pandas rolling function there, and that helps us get to that nice, clean one-liner. Finally, Python is the language of choice for predictive modeling and statistical analysis. It's really unparalleled in that department. So how does dbt work? What are the things that we're thinking about when we're interacting with dbt? There's 4 main pillars that we're thinking about to create this centralized environment that allows dbt to work the way it does. So we have development, documentation, testing, and deployment. We don't need to generate our create table statements. dbt does that for us, and it automatically handles the DDL and DML. For documentation, we have our automatically generated DAG, which stands for Directed Acyclic Graph, and that creates automated lineage so we can see everything from end to end in our entire pipeline. We can implement testing with just a few lines of YAML code. And then one of the most important, and probably one of my favorite areas, is deployment. So you don't want to have an analytics proof of concept that just sits on the shelf and collects dust, or that has to be manually run to be useful over and over again. So we're going to think about deployment. We're going to think about how to get our jobs in an automated way and keep everything that we've produced really useful. So we're going to have job scheduling, and we have our continuous integration development through GitHub. When I think about what it was like before and after dbt, I want to highlight a few use cases that we'll see today. So the first thing that I had in my, my old jobs is I wanted to know what tables were linked to BI applications. Before dbt, I gave a good old shoulder tap to the person, and I said, who owns a dashboard. I said, hey, what tables did you link this out to? And that was really the only way that I would know which tables were being used and consumed by a lot of business users. With dbt, we can use exposures to track both technical and ownership dependencies. So what tables are these relying on, and what person owns that? We're able to locate and debug the correct table. So before dbt, I would Control F, and I'd find the from statement and then the table that I was attached to understand which tables were dependent on each other. With dbt, I use the dependencies lineage that's automatically created through the reference and source functions. The third thing is when I want to check the quality of data, I used to have an ad hoc Git repository that had a bunch of important queries in it, and I would run those and then eyeball the data. So this was manually running the data and manually checking the data. Instead, with dbt, we can create tests with a few lines of code that are checked every single time the job is run. And so the use cases that we're going to support today, we're going to start with a data-driven business question. We're going to say, does it require machine learning? No, we're going to use descriptive analytics. It might, so we're thinking about aspirational ML, which does have its place, where it's about moving up the stack and learning more and more skills and seeing what could be useful to our business. And then we have applied ML, which is we've actually been able to deploy the model. So in our tech demo, we're going to walk through each one of these use cases and show how dbt supports all of these. So how is dbt able to run Python, right? Why are we able to do that now? We're able to do this because of Snowpark. So Snowpark for Python that went GA 2 months ago allows this all to be possible and pretty seamless at that. So we have this GA release, and now we can simply write Python scripts that Snowflake is able to execute. As always, dbt doesn't move your data. Everything is executed on Snowflake. And how this works, to get a little bit more under the hood, is that the dbt code is compiled and interpreted by Snowflake. It's actually wrapped in a stored procedure. So it's creating a stored procedure. And the types of data frames that we use for this is a Snowpark or Pandas data frame. To just get a little bit more in the weeds of this of, okay, how are you actually running Python from your data warehouse? The key things here is that we have our Python secure sandbox. And this Python code can be sort of summoned from that SQL engine. We're also able to use all of the packages because of the Anaconda integration with Snowpark. And this is really important because it saves us from what we call dependency hell. So it works on my machine, but it doesn't work on yours. And I have all these packages, but there's different versions from different times. And like Pikachu is just confused and real sad about it. And so, Anaconda on Snowpark manages this for you. We're going to keep Pikachu happy. So now we're able to run Python within Snowflake. Now let's bring it down within dbt. How do we do this? So I'm going to be showing some of the actual syntax that you can use and what we're going to use in the tech demo to get up and running. How this works at a high level is really similar to how it works in SQL. So dbt Python, it's reading in a model and sources from upstream. We're defining a series of transformations with Python, and we're returning that final data frame. In SQL, what we do is we're using those common table expressions, CTEs, for pulling in that data. We're using SQL, transform our data, and we have a final select star statement. One thing to note before I move on here is that one of the reasons why this works for machine learning is that machine learning is just a complicated transformation. So if we think of it that way and think about a model file plus a transformation, this is one of the reasons we've kind of unlocked all of these new capabilities. It's still input, transformation, output. So what does this look like when you need to get hands on the keyboard and you want to start using Python models? So one of the things we're going to do is we're going to go into our model file here and sort of zoom in on it. So we're bringing in the package that we need. We're creating a function that is allowing dbt to both recognize Python using this dbt argument and then connect into our data, and that is the session argument. Sounds good. Now we have a data frame that was created using SQL. So it's my SQL data frame. We're using the .ref to get that data frame and pull it into our Python model. We're putting it into a pandas data frame. Now, this is the transformation piece that we're applying. We're going to group by our month, and we're going to take the average revenue. And then we're going to return that as our final data frame output. So that's our first Python model in essence. And it's really as simple as that. Maybe you want to configure these models. You want to add a description to say, why did you create this model in the first place, or give it a little bit more context. You want to actually implement tests on it, so make sure that our ID column is unique and not null. And so if you've done anything with SQL, dbt, the YAML file configurations are the exact same. So this way of configuring models, totally the same. That's great. Now, if you're going to do this within the Python model, it's still really easy. We've added the .config setting, and you can see that we now want to materialize this model as a table. Materializations are simply how the object is being rendered in Snowflake. So for Python, this is supported for tables and incremental materializations. For SQL, you can also have those in addition to views and ephemeral models. So it's how it's actually being created within your data platform. We talked about sources and references a little bit in that first Python model. What we can see here is that we can use the ref for an existing model that we already have in dbt. And then if we want to connect into the source, so that sort of leftmost raw data, we just use the .source function. Python models can also be referenced downstream within SQL models. So we can see here we have an upstream Python model. And what we're doing is we're referencing it downstream to SQL. So that's that select star statement there. One of the things that makes Python as powerful as it is are packages. And so we're able to bring in our packages to our Python models, both in YAML and SQL again, YAML and our Python model again. And we can do this simply by using the .config and stating the packages that we have. It can also help to have their versions to standardize that and make sure that everything is running on a same version and consistent. So we have some Python caveats. The first one is that dbt code cannot be reused across models. So if you have two models that both require you to use pandas, you're going to need to write import pandas in each of those models. This is actually an open discussion, something that we're working on so we can have better do not repeat yourself or dry code. The other caveat is that there's a wide variety of syntax implementations in Python. So yeah, there's different flavors of SQL, but there's tons of different ways to solve the same problem in Python because of all that amazing package support. That kind of leads to the last point. There can be longer compute time and higher costs. So SQL can still be more performant and elegant in certain use cases. Here's an example. Pandas is one of the most frequently used libraries. but it's a single-threaded library, which means that we're not able to parallelize our compute and our workload there. And so that's one of the things that can happen. The other reason is that SQL only allows you to have a certain set of transformations, depending on the flavor of SQL you're using. And by nature is a declarative language that our data platforms have been optimized for. Python is object-oriented. And so this is one of the other reasons that it can lead to these sort of longer times and higher costs. All that being said, Python is still amazing and really good at least a couple of things. The first is data munching and preprocessing. There's probably a package for that, whatever you're trying to do. And the reason why that's really cool is you don't need to reinvent code or, even write SQL code from scratch if there's a package to already do that. The other reason is data science. Python is completely unparalleled in data science support and what exists out there. So if you want to do advanced statistics, forecasting, predictive analytics, ML, that's really Python native. So let's take a little bit of inspiration from our use case today and think about what our workflows are going to look like before and after dbt. Here we have Team Ferrari at a pit stop. And what we can see is that the data engineer is doing all the heavy lifting. They're ingesting the data, they're making sure the schemas are correct, and they're going to get that data ready for the analyst. The analyst is going to be ready to go to build those dashboards and different KPIs as soon as the data engineer is done, but they're not able to right now. We're not totally sure what the data scientist is doing here. If they have the same skills as the data engineer, they might be able to help lift a tire, or they might be using deep learning to program a robot to do it for them. We don't know. I think I could make that joke having been a data scientist. Then we have our stakeholders that are watching our analysts and they're like, hey, where's my dashboard? I need my numbers. What's going on? And so you have this whole chain of things that's going on where people are not able to interact with each other's work, either because of the language or the repos and having low visibility. Let's revisit Team Ferrari's pit stop now that they've implemented dbt. We can see a couple of things have changed. So the first one is that we have an analytics engineer as opposed to just an analyst, and they're able to work directly with their data engineer because now they have similar ways and workflows. The data scientist is not directly working with them, but they're working on an adjacent project. So they're not attaching the tire, they're actually working to cool the driver down. So maybe they're working on their own model right now, but they're able to have visibility into each other's work, in addition to the fact that they're contributing the same overall goal, winning the race, or in data world, executing on the same data roadmap and vision. Our stakeholders are able to be involved by directly looking at dbt documentation and seeing down to the table level what rules and tests were applied. So today we're going to use Formula One data, and it's not just because I like Formula One and cars. Maybe that's not your thing, but it's for really three reasons that this data reflects the structure we see in real world use cases. And I'll talk a little bit more about that in the next slide. This is also open source data with a good community around it, and you can sort of riff off and see what they've created and bring it into your own data warehouse with no restrictions. The final piece is that it really supports both analysis and prediction use cases. A lot of times when you're getting up and running to do prediction, everything is pre-cleaned, pre-joined for you, all the feature engineering is done, and that's just not how it looks in real life. So to dig into that last point a little bit, we have our entity relationship diagram, or ERD. And so even if you don't care about cars or Formula One, there's a good chance that you have data at your organization like this. So in the middle, we have this really big sort of meaty results table. And what we have around it are these reference tables to contextualize our data. So within our results, you probably won't remember what driver ID corresponds to which driver, and that changes each year. So we need our reference table here to understand what their name is and what their date of birth and nationality is. Similarly, if we want to know the circuit tied to a result, we actually need to hierarchically join it through races first. So we have that race, the races table, and this connects out to the circuits table. So if you have data that requires a lot of joins, a lot of filtering, these kinds of things, you should definitely be able to relate to this business use case in that way. So we're going to answer some questions using dbt and Snowpark today. We're going to find out what are the top causes of not finishing a race, what circuit has the least finishes. And for those two, we'll just be using some simple SQL group by statements. So this will be SQL. We're then going to find out the lap time average and rolling average through the years. So our car is getting faster. Are those drivers getting faster? Or there's maybe some fluctuations. We're also going to find out which constructor had the fastest pit stops in 2021. We're going to use Python for these transformations here. And we're also going to be able to tie that back out to an exposure. Finally, we're going to go on hard mode. So this is definitely going to be sort of really pushing the bounds of what we can do with all of this technology together. And we're going to predict the position of each driver using a decade of data. And with that, let's jump in and give all of this a test drive. For today's demo, we'll be using dbt Cloud. Now, when you first open up dbt Cloud, you might think it's just the IDE. I definitely used to think that. But there's actually a lot more capabilities built into dbt Cloud. One of the first one is our Git integration and our CI/CD capabilities. So we can have different feature branches and additionally push into main when that code is ready. We're also able to have different development and deployment environments, in addition to having all of our analytics code run on a scheduled job. We're also able to look at the documentation that's hosted within dbt. So this is important to keep in mind. We'll go into each one of these capabilities throughout our demo. Now, to zoom out, we also have 3 main times that we're going to pause during this demo and kind of congratulate ourselves or acknowledge what we've done. The first one is right in the beginning, when we implement the ability to run Python on dbt. The second time is when we run our first .py script to transform our data. And then finally, once we've deployed our machine learning model and we create that table within Snowflake with those predictions on that new data set. So with that, let's get started. So how do we enable Python for dbt? This is really simple. We're going to go to our project YAML file that controls our project level configurations, and we're just going to update that to version 1.3. Boom, that's it, done. Then we're going to go over into Snowflake and make sure that our Anaconda packages are enabled. So we're going to go over here to admin, billing and terms, and agree to the third-party Anaconda packages. So I've already done that. You'll have a little radio box there. Congratulations. We're now able to start using Python within dbt and bring in all these super cool packages. Go us. So for the next part of this, before we get to our Python scripts, we're going to do a little bit of SQL work today. And the reason why you have to do that is before we're transforming all this data in these Python scripts, you need to actually bring it in and join it together. And that's done really well in SQL. So how do we bring data into dbt? We do this through our sources YAML. To do this, all we need to specify is our database and schema and each of those tables that we're bringing in. You may have heard me mention testing quite a bit throughout this, and so that we can implement tests in just a few lines of code. And here it is. We're able to make sure that the constructor ID is unique and not null upon ingestion. Pretty cool. We can also make sure that our pit stops don't have any more stop numbers than 8 of them, because that's kind of the upper limit on those. And so we're making sure we're not bringing in bad data right off the bat every single time we ingest our data. So that's pretty cool. So as we talked about, we need to hierarchically join these tables together. So we have that results table, but we need those races, the drivers, constructors, all of that. And then dbt handles this really well. So instead of having to write and hard code the schema and the table, what we see here is that we have that ref function. And when we use that ref function, we're able to create this lineage automatically for each model. And so here we've joined out a bunch of tables. And now that we've joined out our results and our races at a minimum, we want to bring in our circuit information. So I go over here to fact results, and we can see that I also bring in the circuits table down here. You can see this here. In addition to, I created some aggregation about our total pit stops in that race, and I'm able to join it out here. So you're able to see which tables are dependent on each other. You're able to join them out, create new tables from that. Overall, really cool. So one of the reasons that you may want to do this is you want to have what I'm calling this really big fact table to feed into your BI tool as well. And now we have the ability to slice and dice all this data. We want to understand our reasons for our failures in our race. And so we can use SQL and create a group by statement here. And we can see that we have the engine is the main cause of failure. And then we have accidents, collisions, different things like that. Then we may want to know what's the least completed circuit. So that was the Monaco Grand Prix, and we're able to use SQL to do this. Now we want to connect to an upstream object that we use SQL to create and bring it into Python. So in order to figure out our lap time moving average, here we can see that we're bringing in our intermediate lap times that we cleaned up. We're casting it to a pandas data frame. We're doing some light unit transformations here into seconds. And we're able to then use our rolling mean function here. So this is pretty cool. And we're able to go ahead and get that result. And we can see that it seems like lap times had been decreasing, but actually along here, when they had changed the rules of the car, like the car formulation, they bumped up. And so we're able to have that lap time and our moving average together there. So awesome. We were just able to create our first Python model to transform our data. And so now we're using SQL and Python together really pretty seamlessly. We also want to know who had the fastest pit stops. And so in order to do this, what we're able to create from here, we use very similar to what we use for the lap times. One of the differences here is I'm calling this describe function. And if I go and I look at the output of this table, you can see that Red Bull in 2021 had the fastest pit stops, the lowest mean, in addition to the lowest standard deviation. Now, if I were to do this in SQL, I would have to create a column for each one of these and call the percentile functions for the 25th, 50th, and 75th, and so on. So here, if I go back to my Python script, I can do that with just the .describe. So this is a case where Python is really elegant in its code. Cool, so pats on the back, we just created 2 new data frames using Python. Good job. Now what we're gonna do is show the aspirational and production ML use cases. We're definitely going into hard mode here, and we're not going to dig in line by line. So we're gonna do some additional data prep. So first, we're just going to connect into our fact results table, our big table. We're going to filter the data down to the last 10 years. We're going to fill our pit stops with 0 if they're nans. Machine learning algorithms really don't like nans, and you need to encode this data down the line. So we could make an indicator variable and still then impute this, but this is how we're going to handle this today. There's been some rebranding in Formula One the past few years, if you follow along with that kind of thing. So we want to homogenize these teams. We're going to create some very light feature engineering for our drivers and constructors and see how reliable they are in finishing races. And then finally, we want to filter by the active racers and the active constructors or teams. So that way we're not getting some weird erroneous predictions that someone from the 1950s is most likely to win a race. That would be weird and bad. So we're filtering that out as well. Cool, we've cleaned our data. Now in ML, we need to encode that data. And so what we're mainly going to use here is the label encoder. And so we're going to do that especially for our categorical variables. One of the other cool things that you can do within dbt Python is it supports this function within a function. So we have our dbt connection function, but we also have the ability to cast our positions. So what we'll be predicting today is whether the person was made podium, so they were in the top 3. We'll also be saying, were they in points? So did they make the top 10, but not the top 3, or did they get no points? And they finished from 11th to 20th. And that's third category. Cool, we've now cleaned up our data. We've encoded it so that algorithms understand it. And now we want to split out our data. So we had 2010 to 2020, and then we encoded that data. But now what we want to do is for algorithm development for this aspirational ML, we want to use that 9 years of data for looking at different models, but we need to have a holdout set. So we have a validation set, and this is going to be just from the year 2020. So we essentially run a whole bunch of different classification models for that position. So we have a logistic regression, support vector classifier, decision tree, and a k-nearest neighbors classifier. And we can look at the outputs of each one of those while we're doing this mel. And so for the first one here, we can see the actual position. So that's our position label, the logistic regression, decision tree, and the nearest neighbors got it right, and our support vector got it wrong. So now we may want to know what was our most accurate of all of these algorithms across the 4 that we're choosing from. So we're going to perform a cross-validation. This is all still within dbt. And one of the really cool things is this may have been in Jupyter Notebook cells before, and you can drop this right into dbt and you can render these data frames back out. So this is really powerful. So we perform this cross-validation across our different models. We want to see how accurate they are, and then we want to look at that output. So we can see it seems like our decision tree was like perfect, but this is not an ML lesson. We're focusing on dbt today, but we are pretty sure that this is way overfitted, and we know that. So if we dig into that, we would know that. So the decision tree classifier has overfitted our data. We need to constrain it if we were going to use it. The support vector and the k-nearest neighbors, they are kind of operating on similar distance algorithms, and they didn't perform as well. So today we'll be using our logistic regression as the model, now that we're done our aspirational ML, that we want to scale. This is also one of the most compute-friendly algorithms out there as well. So that's definitely good for our example. Great. So we have that holdout set. We have our logistic regression, and we've chosen it. So now we need to train our logistic regression, and we need to save this trained model to a file, a staged file within Snowflake. Big shout out to Etta here at Snowflake for some of this code, and definitely really helpful with some of Snowpark's capabilities. Thank you so much. And I'm not going to go into this line by line, but we'll be doing a workshop on this next month, and I'll talk a little bit more about that. So here what we're doing is we are creating a function to save the file. We're creating our stage. So we need to actually save our trained model file to that stage so we can reference it back on our new unseen data to create new predictions on. We're splitting it into a training and test set. We're fitting that, and now we're saving that trained model here. And so I'm going to go back into Snowflake to show this. So if I go into the data area and I go into my development schema, I have a stage here. I have my model stage. Okay, that looks good. Now, how do I know that there's anything actually in that model stage? We're going to list out the items here, and we can see that I have my trained model saved here to predict the driver's position. Cool. Now what we need to do is apply that trained model on this new data. So we're bringing within this dbt Python model, we're bringing in that file. We're bringing in our new unseen data, and then we're creating those new predictions. And we can see that here, so that we have our predicted position. So that's pretty cool. We were able to do each one of those things. We were able to show kind of like a slim ML ops. Remember, we're still in the experimental stage with this, but this is some of the cool stuff that you can put together using dbt and Snowpark. I'm going to show our documentation real quick. So we had different tests and different description for our models throughout our project. And so if I go in here to our documentation website, you can see that there was many pit stops. We had a one-to-many relationship. We need to aggregate it to avoid a fan out. Cool. You can also see what this was referenced by upstream and downstream. We have our source and compiled code. We also have our mini lineage just for this pit stops, this intermediate pit stops table. But we also are able to view our project level DAG as well within the documentation. And we can see that in my project YAML, I also configured some color codes to the node depending on their directory. So that's pretty cool to help see what's going on in each one. So we've done all this really cool work, and we've been able to show how we're able to take a ML algorithm and deploy it within our development schema But now we want to actually put this into a production space within our data platform. So if I go back to Snowflake here a little bit, one of the things that we can see is that I've been working here in dbt H Watson. I now want to create a production schema. So the way that we're able to do this, we go into our environments. So we have our development, our deployment environments. And then we want to go into our deployment. And we can see that we're able to schedule these jobs. So I was able to run this. I see everything that I was doing on my development branch. I'm now able to very quickly bring it into deployment. And I can also look at the model timing of each model that I had. And so we see that encoding and predicting positions took the longest. They're really the most compute intensive operations that we had. And we also have an output file of everything that we tested.